the change to be plus 20 dB per decade. Okay, I'll share these sheets with you. You can check out later on also. So the conclusion is, if the factor is in the numerator, the slope contribution per decade, please do not forget that per decade, because our reference is what is the magnitude change in one decade, and that is why slope contribution per decade for a factor in numerator is plus 20 dB per decade, and for factor in denominator minus 20 dB per decade. Okay, now let us go back to our original problem. Okay, so now see this, the third column, slope contribution per decade. In this case, for first one, again, there is no frequency. This factor will contribute throughout the Bode plot, throughout the magnitude plot. Phase contribution by K is 0. So this will not contribute in phase, but it will contribute in magnitude of the transfer function. Okay, so slope contribution is none. 1 by j omega, just now we have seen this factor is in the denominator, so slope contributed is minus 20 dB per decade. This also is in denominator, minus 20 dB per decade. This is in numerator, plus 20 dB per decade, denominator minus 20 dB per decade. Now the next column is nothing but net slope. So net slope is initially slope, I mean this is not contributing to this. So from origin, slope contributed is minus 20 dB per decade, as you have reference here. Okay, now at 2 happens, at 2 this factor starts contributing. Once another factor starts contributing, the slope will change, and by how much it will change? Minus 20. Already slope was minus 20, plus it will change by minus 20. So minus 20 minus 20, net slope would be minus 40. Okay, next, up to next corner frequency, the slope would be minus 40 dB per decade. At 5, what happens? Another corner frequency, so this factor starts contributing. It will contribute plus 20 dB per decade. Initially now it was minus 40, plus 20 it will add, it will again become minus 20, minus 40 plus 20, so minus 40. This will continue till next corner frequency. This will start contributing minus 20, so minus 20 minus 20, again minus 40. Okay, and last is frequency range. This doesn't have a frequency range, it is for all the frequencies. 1 by j omega. This factor, effect of this factor is from what? Origin to first corner frequency, right? Only this factor we are talking about. So initial to 2, frequency range is initial to 2. So from initial to 2, the slope of the magnitude plot is minus 20 dB per decade. This will continue up to what? 2. After that, the slope will be from 2 to next corner frequency, that is 5. Then from 5 to 10, and then 10 onwards. So last 2 columns of this magnitude are used for actually sketching the magnitude plot. Okay. Now, please turn on your audios and let me know which part is unclear or everything is clear.
Understood, ma'am.
Sorry?
Everything is clear, ma'am.
Everything is clear.
Okay. So net slope and slope contribution and frequency range, everything is clear? Okay.
Yes, ma'am.
Yes, ma'am.
Okay. Now we'll move on to the phase equation part. This phase equation part is, we can write the phase equation for the transfer function, including all the factors. Now here for that, we need to have this transfer function again. So in magnitude, what we did, we separated out all the factors and then found out what is its slope contribution in order to sketch the magnitude plot. Similarly, for phase plot, you need to separately consider each factor and then see its phase contribution. How much this 10 is contributing in phase, how much this 1 plus j omega by 5 is contributing, how much 1 upon j omega is contributing, and so on, right? So we have seen in the last session, we have seen phase contributions by individual factors. So what is phase contribution by open loop gain? K, 0, because imaginary part is not there, right? So phase contribution is 0. So this factor will not contribute in phase. Then 1 upon j omega, 1 upon j omega contributes minus 90 degrees. You can go back to the formulae and minus 90 degrees. So pole at origin will contribute minus 90 degrees. If it would have been 0 at origin, it would have been plus 90 degrees. Okay. And then here we can see this factor will contribute plus tan inverse of omega by 5 because this factor is in the numerator. Now for these two factors, both are negative, minus tan inverse of omega by 2, minus tan inverse of omega by 10. So by adding all of that, you can write the phase equation as minus 90 minus tan inverse of omega by 2 plus tan inverse of omega by 5 minus tan inverse of omega by 2. Here you need to take care of the signs because people might make mistake in that. Okay. Now phase table is nothing but for various values of omega, what should be corresponding phi. So suppose value of 5 is 0.1, then 0.2, 0.5. These are in general, conventionally, these values are taken for calculation of phase equation. Okay. Now, in your calculators, there is a note written here. In your calculators, you have the feature to add the whole equation at a time and then just keep on changing the value of omega. Okay. So feed phase equation in calculator directly and then just for various values of omega, what is value of phi, you can write it down. I have not written the complete table. Okay. Because then once the table is ready, you just need to plot it against various values of omega. Now, one more point I would like to mention here. In this phase equation, you can write the equation in any sequence, like whichever factor comes first, that should be only first. That you can, hello, you can use any factor initially and then can you please mute? Please stop the audio, all of you. Okay. Now the problem is here. If suppose I write this factor below 1 plus j omega by 5, it will be considered that this factor is contributing after this factor, and so net slope would be wrong. That is why it should be written in ascending order of corner frequencies, because for the calculation of net slope, we need to know exactly at which point which factor starts contributing, and that has to be in sequence of corner frequencies. Okay. So once magnitude table and phase table is clear, then you will be able to sketch the magnitude plot and phase plot on semi-log paper. Okay. Now please turn on your audios. Yeah. Have you understood the magnitude table?
Yes, ma'am.
Yes, ma'am.
Sure.
Yes, ma'am.
Yes, ma'am.
Okay. Now, the slope contribution, I mean, how to calculate slope, that also should be understood. Even if you remember that for negative, for factors in denominator, the slope contribution is minus 20. And for factors in numerator, slope contribution is plus 20. That should be sufficient, but you should know the behind it also. So I'll share these files which I had opened, solved on my own. And now we have come to the last part, that actually sketching the Bode plot, and then calculation of gain margin, phase margin, omega GC and omega PC. That we will be able to do probably tomorrow. Tomorrow one session we will have, because I do not have semi-log paper with me right now, and I don't think any one of you will have that. But you have a textbook, Probably they might have printed it in the textbook in the soft copy, get an idea, and I'll try to draw it on my own. I mean, just to give you an idea how the semi-log paper looks like and then how to plot it. Okay? But there is a limitation. Let me tell you, there is a limitation. I can't show each and everything unless I have semi-log paper with me. So just go through the books, those who have the books. If you do not have the book, please ask your friends to send a snap of that particular problem which is solved in your book. Just revise and try to solve on your own, and then tomorrow we will again sit and discuss what the definitions of gain margin, phase margin, gain crossover and phase crossover. Your today's task would be to go through all the sheets that I have circulated, solve one or two problems up to writing or completing magnitude table and phase table. Is that clear? Phase table calculation
Okay, ma'am.
be accurate,
Yes, ma'am.
because people make mistake
ma'am.
in calculation of phase. Just try to feed the equation in your calculator, and then that should be fine. Okay, is that clear?
Yes, ma'am.
Yes, ma'am.
Okay. Corner
Yes, ma'am.
frequency concept is clear.
Yes, ma'am.
Yes, ma'am.
Yeah, if you are solving problem or just going through problems today, and then if you have any difficulty, please just send a message to me, WhatsApp message to me. I would, if you would like to address the difficulty in the forum tomorrow, we will discuss it there, or otherwise I'll clarify the doubts individually also. Okay.
Yes,
Yes,
ma'am.
ma'am.
Okay, ma'am.
Yeah. So that's
Yes,
all for today.
ma'am.
Just a minute. I had planned a session on Nyquist plot tomorrow, but I think we should, because unless you get conversant with all of the concepts in Bode plot, we shouldn't go for Nyquist plot. And in 2 days, 2 different topics would be for you. So tomorrow we are not going to have Nyquist plot session. Tomorrow we will have Bode plot session at what is the convenient time? 1:30.
Okay, ma'am.
Okay,
Fine.
ma'am.
Okay, so
Okay,
at
ma'am.
1:30 we will have last session of Bode plot. Please be ready with your doubts if you have any. If there is any problem in the textbook that they have solved and you have not understood, just send a snapshot to me on my WhatsApp. I will clarify the doubt. Okay.
Okay,
Yes,
ma'am.
Okay, and I'm sharing, Shivam, I'm sharing all these papers which I have, which are handwritten. I'll share it. Please share it with your class.
Yes, ma'am.
Okay. Thank you all. You can leave.
Thank you, ma'am.
Thank you, ma'am.
Yeah.
Thank you, ma'am.